The human brain is naturally wired for survival, a trait that historically required a negativity bias, prioritizing threats, mistakes, and dangers over safety and rewards. However, modern neuroscience reveals that practicing gratitude can consciously override this ancient programming. Far from being just a fleeting feeling or a polite social custom, gratitude acts as a profound catalyst for neuroplasticity, fundamentally altering the brain's structure, chemistry, and neural pathways. When we actively practice gratitude, it triggers a cascade of chemical reactions that alter our immediate mental state and leave lasting changes. The neurochemistry of feel-good pathways. At the biochemical level, gratitude primarily stimulates two main neurotransmitters responsible for emotional regulation and reward: dopamine and serotonin. Gratitude practice triggers dopamine and serotonin, activates reward and regulation pathways. The dopamine reward loop. When we identify something we are truly grateful for, the brain releases a surge of dopamine. Because dopamine is the neurotransmitter linked to pleasure, satisfaction, and motivation, this surge creates a natural reward loop. The brain essentially notes, "That felt good, let's do it again," making it easier to notice positive things in the future. The serotonin stabilization effect. Simultaneously, gratitude acts on the brainstem to produce serotonin. Serotonin acts as a natural antidepressant and mood stabilizer. By increasing serotonin levels, gratitude relaxes the nervous system and enhances feelings of security and contentment. Rewiring structural pathways. The brain changes structurally depending on what we focus on. Brain imaging studies, particularly those using functional magnetic resonance imaging, fMRI, show that practicing gratitude significantly activates the medial prefrontal cortex, MPFC, and the anterior cingulate cortex. These regions are heavily involved in regulating emotions, managing interpersonal bonds and empathy, assessing the morality of fairness. Regularly activating these regions strengthens their neural connections. Over time, the MPFC becomes more efficient at regulating stress and processing complex social interactions. Furthermore, gratitude practice has been shown to downregulate the activity of the amygdala, the brain's fear and threat detector. A quieter amygdala means a reduced baseline response to anxiety and stress. By shrinking the impact of the amygdala and boosting the prefrontal cortex, gratitude shifts the nervous system out of a chronic fight-or-flight state and into a rest-and-digest state. Long-term benefits and neuroplasticity. One of the most remarkable findings in neurogratitude research is its long-term, self-perpetuating nature. In a notable study by researchers at Indiana University, participants who completed a brief gratitude writing task showed significantly greater activation in the medial prefrontal cortex months later compared to those who didn't. This suggests that gratitude is a skill driven by neuroplasticity, the brain's ability to form new neural connections. The more you train your brain to find things to appreciate, the more naturally it scans the environment for positives rather than threats. The neuro takeaway. Gratitude does not erase life's difficulties, rather it changes how the brain interprets them. By consciously shifting focus from lack to abundance, we transition our neural architecture from a defensive posture to an open, resilient, and adaptive one.